Hey everybody, it is a little after midnight on December 1st, so obviously it's time for Advent Code 2023. The first day, of course, is a little bit easier than usual. Today's was probably slightly harder than the last couple of years, but still pretty quick. Basically what we're going to do is we're going to get a file, and each line has a string, and in this string there's at least a couple of digits, and we want to take those digits and concatenate them into a number. And then once we do that for each line, we're going to add all of them together. So this first line, we have a 1 and a 2, so we're going to have a 12, and then we're going to make that as our number, add it to the total. Second line, 3 and 8. The third line, again, we only care about the first and the last, so we want 15. 2, 3, 4, throw them away, we don't need them. And then we're going to go through and do all of that over and over until we've completed our task and got our sum. So how we do that in Kotlin is, so I have I'm using the Kotlin template, so it has a function here to read input into a list of strings, and then I'm going to send that list of strings into my function and return a integer, which is the total. And then the way I started this was just a total, and then for each line in our input, we're going to split this line into a character array, so a list of all the characters in this string. And then at which point we can filter out all the characters we want, basically. So we want to take in all the characters that are inside the range of character 0 to character 9. This is kind of a clever little way of ignoring, just not having to do ASCII math or any of that stuff. We're saying that all the characters that are between the ASCII character 0 and the ASCII character 9 inclusive, we want to keep. Everything else we don't want to keep. We can do the same thing with like A to Z as well. Just good shorthand to know so you don't have to look up any values or anything. And then once we have that, we're going to add our total of the first digit and the last digit. We're going to turn those into strings. Partly it makes the concatenation easier. String concatenation is kind of built in. But secondly, we can also then use our string to int function, and this is going to take our string value of 1, 2 and turn it into the binary value of 12. And so it makes it really quick and easy to use that without having to do any sort of changes on your end. So we're basically go through there, do that, spit out our total, good to go. After the fact, I also went through and did the same thing in a more Kotlin-y way. So we're going to basically do the same thing. We're going to take for each line, we're going to take our nums, or make our nums, which is a character array, filter out the characters that we care about. In this case, I'm using the string builder to do our concatenation for us, and then straight to int. And all of this will go into a map, and then we're going to take the sum of that entire map. So it does the exact same thing as part 1 up here. It's just a little bit shorter and more Kotlin-y kind of way to do it. So then we get down to part 2, and of course part 2 is always a little bit harder. And so it turns out some of our lines actually have the words or the numbers spelled out. So like TWO should be not skipped over. We need to replace it with an actual 2, and so on. And so the way I did this is basically I just did for each line I did a simplified, which is the line replace 1 with the value 1, or the decimal 1, and then replace 2 with the digit 2, and so on over and over. Now you'll notice I have these in here like 2, 2, 2, and the reason being is the curveball is that some of these are overlapping. So like the first digit or the first letter of the word 2 is the same as the last letter of the word 8. And so when we're doing this, if I replace the 2 first, I now have an A and not an 8, and the 8 doesn't get replaced. And so by replacing it with 2, 2, 2, like what happens is we'll take this 2 out, and we'll then replace it with 2, 2, 2, and the 8 would still match. And if there was a 1 after this, it would still match. Probably not really the correct way to do it, but still pretty quick. And I don't know if like specifically they want us to replace all of them, or if we only have replaced the first ones in each string or each overlap or what. I suspect it's probably designed to not matter. but that definitely works for me. I also went through and made a slightly more compact example where basically I took a list of pairs of the original string that we want to look for and the one to replace it with. And then basically we just loop through the replacements and replace on each. One of the things I did on here also is that instead of doing 1, 1, 1 or whatever, I only use the characters that were actually going to overlap. And so, for example, like 6, there are no digits that end with an S, and there are no digits that start with an X. So I can just replace it with 6. I don't have to worry about any replacements for the characters. Same thing with like 9. There are some that end with an N, like I guess 7. And there are some that start with an 8 or an E, 8. And so basically, I need to have at least the N and the E, but I don't have to have anything additional. So it's a little bit smaller, probably a lot less easy to read though, so I'm not sure which way I would do it in real world, but probably something a little bit more clever. Either way, everything of course is on the GitHub down below, and if you have any questions, throw a comment in the chat. And other than that, I'll see you tomorrow.